So today what we're going to do is we're going to look at different sized holes in our groups, and we're going to explore different sized holes with pattern blocks. So what I'd like you to do is to go back to your groups, and then I'm going to pass out the pattern blocks and explain the directions. Can you pass out just the pattern blocks to people your page? Operator, can you just pass out the pattern blocks? Not the paper, but just the pattern blocks. There may be some extra pattern blocks, that's okay, just leave it in the basket. I'm going to ask some table monitors to pass out the pattern blocks. Elizabeth, can you only pass out the pattern blocks, not the paper? If you have extra pattern blocks, just put it back in the basket. Sumaya, can you pass out the pattern blocks to everyone at the table, just not the handout?
Pass them out. I tried with hexagons, and yeah, I needed more triangles.
So what I'd like you to do is to take the pattern blocks out of the Ziploc bag and see what relationships and observations do you notice about the pattern blocks. So in other words, establish one pattern block as a whole and see what relationships you discover. So for example, what I mean by that, if you use two hexagon blocks, right? So everyone put two hexagon blocks next to one another. So if you use two hexagon blocks to represent the whole, what fractional part of the whole will one hexagon be? Romeo? A half. Okay. What about, we still have two hexagons as our whole. What fractional part will represent a fourth? What fractional part will represent a fourth? Ondine? A trapezoid. Can you say a little more about that?
Trapezoids would represent a fourth because I know that two trapezoids placed on top of each other like this makes one hexagon. So four of them probably four of them.
Okay.
Like this.
Oscar, can you hold on? Okay, so now I'm going to give you some time, I know you're exploring, to see what kinds of relationships you notice when you establish something as the whole, okay? Whether it's two hexagons, one hexagon. Say that again?
Sure. I'm exploring. Somebody stole my piece. Oh, nobody stole it.
Okay, so take a pattern block and establish something as being the whole. Okay, so what do you want your whole?
I made a triangle. I have less than what shape is this? It looks like a diamond.
So what do you notice about, so this is our whole, what do you notice about the other pattern blocks?
Like they can make a hexagon. that they can, if they're put together, they can make a hexagon.
Such as?
Three pieces, like, or 6 triangles can make a hexagon.
So let's talk about what Alexa just did. Okay, so let's talk about this. So the whole, Alexa, was what? What did you start out as the whole?
I started out as I made a hexagon using 3 rhombus's, and so if each part would be 1/3 of the hexagon.
Okay.
Put them together to make one whole.
Okay. So 3/3. Okay. Which is
one whole.
Which is a whole. Okay. So each part of the rhombus represents
1/3.
what fractional part? A third. Okay. And then when you put them together, it represents
And one whole.
one whole. Okay. Do you see any other relationships?
2.
When you make something a whole, whether it's okay.
And each one will be 1/2 of the hexagon, and both 1/2 would equal one whole.
Okay.
You can make them into 6.
Can you say a little more?
Well, you can make them smaller, so the number would be bigger, and you can use 6 triangles to make a full hexagon.
Okay.
And each triangle would be 1/6.
Would be 1/6. Okay. Thank you. So keep doing that. Designate something as your whole and see if you can find relationships between the other pattern blocks. For example, what fractional part would another pattern block represent in something as your whole? Okay?
I did it already. No. Look, I put them on my desk. Okay. So here, you can use triangle. You can so wait. Excuse me. You said your desk. I know that. So now, so you have 11. And one hexagon can make one hexagon. Go. No, we can't. Yes, you can. I know. Let's swap this for this. Give me all your time. Wow.
Would anyone like to share what they observe, what they notice?
Oh, I know.
And you have to start out with something being the whole, okay? So now let's track the talker. Let's pause with the pattern blocks. Track the talker. Ashton?
So my goal is 2 hexagons, and it takes 4,
We're tracking the talker right
it
now.
takes 4 trapezoids for 2 hexagons, 12 triangles for 4 trapezoids and 2 hexagons, 6 triangles for 4 trapezoids and 2 hexagons, and 6 rhombuses for 12 triangles, 4 trapezoids, and 2 hexagons.
And what was your whole, Ashton?
My whole is 2 hexagons.
2 hexagons. Okay. Would anyone else like to share before we move on to the activity? Ashton, why don't you call into one?
I use 1 hexagon as my whole, and what I did is I thought that all these pieces. Wait, if all these pieces are together, shouldn't they have some symbolic relationship? And then I looked at it and I saw that
if you put them, if you keep on going up and adding them on top of each other, it will always end up as a hexagon.
Can you say a little more about that? Is that building on what Ashton said? And was your whole one hexagon or two?
One.
Will it work for 3 hexagons? What if your whole is now 3 hexagons?
Well, then it wouldn't work because you need more trapezoids, more triangles, and more rhombus.
Okay. Will the size of the fractional part, does it affect the whole? Does the whole affect the size of the fractional part? Can you say a little more?
In this, the bigger the whole, the bigger the fraction will be, because the more pieces that you'll need to create one whole.
Okay, so right now we're going to do an activity, and we're going to sort of explore further and think about what Shane just said. So the activity, if you look at the smart board, you're going to complete the handout. It's called Pattern Block Riddles with your Think, Pair, Share partner. And the handout is inside of the bins, okay? So in a minute I'll tell you to pass it out with the same table monitors. And then if you happen to finish before I call time, I'm gonna give you about 15 minutes. It's 2 pages, the Pattern Block Riddle activity. And then after the activity is an exit ticket, which has 4 questions. So I want you to complete that. So the 2 pages with the riddles, and then the next page is the exit ticket. And if you finish that before 15 minutes, I do have a challenge for you to work on. It's called Whole Lot of Fractions. And I will leave the challenge up front beneath the Think, Pair, Share partner poster, so you can just come up and get it. But you will only come get the challenge after you finish the first 2 pages and the exit ticket, okay? So you have 15 minutes. Can I get my table monitors to please pass out the handouts? So that was Sumaya, Alfredale. They're inside the basket.
Can I borrow this? No, this. I did that, but put the 2 yellow ones on top. I did release the most.
If you hear my voice, clap the quotient of 42 divided by 6, which is 7. I overheard Alexa say something, and it's part of the directions, which is very important. So I'm going to read the directions aloud to you. It says task, pattern block fractions. Use the pattern block to solve the riddles below. Draw the shape and label each fractional part. So we did the first one together as a class. So if this is 1 whole, meaning the 2 hexagons, what is a half? And I believe Romeo said earlier that it's 1 hexagon, right? So then what you would do is you would draw it. You would draw the hexagon over here, okay? And then label, so you could trace it, you could trace around it, however you want to do it, okay? But it's important that you do label the figure, and so I know which figure answers a particular question. Is that clear? Okay, so you're going to work with your partners right now.
I made a pyramid, but then I forgot how to do it. I don't remember how to do my pyramid. Oh, I know. Yeah.
this one together, Romeo. Okay, so if this is one whole, what is a half?
H and this, but
So this is your whole. Okay. So if this is a whole,
it's
the
a
two
gender
hexagons,
con.
what would a half be? Okay, can you prove it?
Oh, do the same thing for this. Oh, this is.
Okay, so what's the whole?
We're supposed to
To what? 2/3?
one half.
Okay, here, read the question.
Is this one whole? What is one half?
Okay, so what is the whole? Was the trapezoid there?
Before it was
Okay. 2 hexagons. Okay, so what would the whole be?
the whole would be one half. It would be a trapezoid and another trapezoid. Or it would just be half of the hexagon.
Half of the 2 hexagons?
One.
It would be 1. Okay, so if you have to write the answer over here, what would you write? So let's start from the beginning. So if this is one whole,
Do one of them.
what is a half? This is a whole.
Trapezoid. This is the final.
Okay, can you show me? Now, why did you take that out?
I took it. Are you even doing it? Yeah. This is one part of the whole.
Okay, that is one part.
But if I put another trapezoid,
It'll create a hole for just this one hole.
yeah.
But the question is, this is so okay. So if this is a hole, just the hexagon, one hexagon, you're saying that this would be a half. And tell me why.
I would say that would be a half because it's half of the fraction one half.
Okay.
Because it's like one whole.
Can you prove that? Can you show me?
Also, this is special.
Okay. So then if this is the hole, then that would be a half. Do you agree? You mean, I'm saying, you mean that one trapezoid would be a half if this is a hole. Okay. So what if now this is no longer a hole, but 2 hexagons. 2 hexagons. This is your hole now.
1/4,
So your hole is now changed from 1 hexagon, right? Your hole before was 1 hexagon, and before when it was 1 hexagon, we said that, you said that a half is a trapezoid. Okay? Yes. So now your hole is now 2 hexagons. So what would a half be? What would a half of this be? 2 hexagons.
What? Well, sure. I'm talking about
Okay, can you show me what the pattern was? Because it says draw the shape and label each fractional part. So can you find one shape that would represent a half for this? So this is the hole right here. The 2 hexagons.
I determined.
That's a hole.
6 triangles.
Okay. Okay, so 6 triangles. So if we wanted to make 6 triangles, just one of these shapes, what could we use?
Are you done with the first page? What do you mean?
Out of these pattern blocks, and I borrowed some from Rena because you're kind of using the pattern blocks that you have in your Ziploc bag. If because you said a half would be 6 triangles. So my question to you, so then these are 6 equal pieces
If you do triangles,
combined to create a whole. So if
if you
you
do rhombuses,
pick
it's exactly
just
6.
one pattern block, which shape would you choose to represent a half of this? What you said is this. Can you see another shape that is just one? But that's one, and then you would need another one, right? Now it's 2, right? Another hexagon. Okay. Another, yeah, because you were out of hexagons. So if you saw the hexagons, if you saw another hexagon here, then it might help you. That's exactly why I took the hexagon from Lena's guy, because you use both your hexagons over here. So you're saying now the half is this, right? If you're talking about one shape.
Yeah.
Okay.
It would be another hexagon.
It would be another hexagon. So before, your half was this, right? When you had one hexagon, your half was this. And then when your whole is this,
I made a pentagon.
and you wanted to represent a half, it says
I made a pentagon.
using to draw the shape meaning one figure, you said it was this, right? So my question to you, this is a half, but this is a whole. This is a half, and this is a whole. So my question to you is one half always the same size?
4, 5, 6.
Is one half always the same size? Well, let's see. Let me get a piece of paper. Okay. So do me a favor. Can you fold this into 2 equal pieces?
This side.
However you want to fold it.
I'm ready to get it all down.
Just 2 equal pieces. And then label each part what fractional part it would represent, if that's the whole, that piece of paper.
Okay, I know.
So then label a half. Label what each part would be, each fractional part represents. So in other words, this is a whole, so you've now divided this into 2 equal pieces. So if you had to label this as a fraction, right, what would this part represent? What would this part represent? Okay, can you write that with a pencil? You could either talk about the hole on the first page or the hole on the second page. Okay, so now label the other side, please.
There's another half.
Okay, so now I'm going to give you a different size paper, and I want you to divide this into 2 equal pieces. And then label fractional part would be a half, okay? And then this is the whole. So then now my question was,
This is easy.
in the beginning, our beginning investigation, this is the whole.
I use all my shapes.
And then I asked you what represents, which fractional part represents a half. And you said it was this, this is a half. Trapezoid. Okay, so this is a half. And then when this was the whole, 2 hexagons, I asked you to find a shape that represents a half. And what did you say it was?
For a half.
For the two hexagons. This is now a whole.
Okay, that was just confusing.
You said it was.
Oh yeah, it was
And then, when I asked you to fold this paper in half, you said that this represents a half. Right? And this represents, give me 1 minute, Steve. That represents a half. And then when I asked you to fold up this paper, you said that this is a half and this is a half. So notice how the half is changing. When this is a whole, this is a half. When this is a whole, this is a half. When this paper is a whole, these two parts are half, and same with this. So my question to you was, in the beginning, is one half, one half, one half, one half, one half, always the same size? No. Why not?
It depends on
It depends on.
the shape. Look what I made.
Okay.
I should try to compare.
Okay, so in other words, it depends
It looks like a bat to
on
me.
the whole.
Don't
right?
take it away.
So this was the whole, right, at the beginning.
Don't touch
And
it.
so then this was a half. This was a whole, two hexagons, and this was a half. This was a whole, and then that became a half, and this was a whole. So the size of the whole changed each 4 times, right? Every time the whole changed. So because the whole changed, the size of the half is going to change, right? Because when the whole was just this one hexagon, it was this smaller trapezoid, right? But when it was 2 hexagons, it was larger than this, right? Because this whole was larger than that. So therefore, it affected the half. The half became larger. So now what are we going to say about comparing? Because
You did it? It said if the denominators are the same, or we compare the numerator, and one goes like this. Or you put one whole. So
boys and girls,
we'll get some different size.
the buzzer just went off. So thumbs up if you're still working on the handout. Thumbs up. You're fine because we're working together. Okay, so I'm just going to put about maybe 3 more minutes on the clock, and then we're going to share some of our observations, okay? Thank you.
You could choose either one because
Or do you have to choose 10?
no, you have to choose one of them, like this or this.
Okay, for example,
Why don't you read the question?
How to choose from the holes and choose to the hole.
Okay, so now let's look at it. So let's keep back to page 1 and page 2.
Because from this question, on page 1 is 1/2.
So Carter, can you be the paraphraser and sort of reword what the question is asking? Alexa, you're listening to Carter.
How does the size from the shape on page 1?
Tell Alexa.
How does the size of the shape on page 1 change on the shape on page 2?
Okay, so let's
there's
look
still
at it.
1/2.
Okay.
Because like page 1 is bigger, except page 2 is smaller. Because they're both still 1/2. Because on page, like Ricardo said on page 1, the 1/2 is bigger than the 1/2 of the second page.
Okay. Why do you think that is? if I have a half of?
No, it's not always the same size because this shape is bigger than this shape, so you would use a different shape to divide this in half than you would to here.
Okay, so can you prove to me that 1/2 isn't always the same size? Looking at question number 1.
Let's see. So, like question number 1, this shape is bigger. It's because it's this.
One more minute and then we're going to share.
Because that shape is this, and you have to divide it in half. One hexagon would be the 1/2, and on the second page, the question number 1 is this, and this shape is bigger than this shape, so you would use different shapes to divide it in half.
So why did the size of the half change?
Because the size of the shape changed.
The size of the shape or the size of the
Half.
of the whole, right?
The whole
meaning the shape,
changed
meaning the whole. Because on the first page, the whole was what, Alexa?
Because on the first page, the whole was 2 hexagons.
And so half would be what?
1 hexagon.
Okay. And then on page 2,
The whole was 2 rhombuses.
okay. So then what would a half be?
1 rhombus.
Okay. So that's what that question was asking. So now let's go back to the question. Let's look at the question. Okay, so read question number 2.
How did the size of 1/2 change from the whole on page 1 to the whole on page 2?
Okay. How would you answer that? What would you say?
I would say the size changed because the shapes that are used to make 1/2 of each shape is a bigger shape than on page 1. It's a bigger shape than the shape on page 2.
See, you understood the question. Thank you. Okay, so we're going to pause. What I'd like for you to do is the following. Please put your pattern blocks back in your Ziploc bag.
To find it. So
If you combine, pattern blocks, that's okay. We'll sort it out later.
Oh,
So just
we
put them
already
back in
sorted
the
it out.
Ziploc bag. If you need a Ziploc bag,
1, 2,
raise
3,
your
4,
hand.
5.
Cheyenne,
Wait,
do you
1,
need a
2, 3,
Ziploc
4,
bag?
5, 6, 7, 8, 9, 10, 11,
Okay.
12, 13, 14. I take 7. 1, 2, 3, 4, 5, 6.
Okay, you know what? Why don't you give us some back,
7.
and then we'll sort it out later.
1, 2, 5.
We'll sort it out later. Okay, looking for a table that's ready. By ready, I mean your pattern blocks. You're putting the pattern blocks inside your Ziploc bag. And you're putting the Ziploc bag inside of the bin.
The second question is
And you're just leaving the bin on the table.
cut it in. And then wrap them up.
Cruz, can you put your pattern blocks
And
away?
then pick them up.
Excuse me, Shania.
Angel, look, I'm trying to cover every hole.
So I'd like to go over some of the questions. So pencils down, please. Eyes on me. So normally we would share on the rug, but I want us to sit at our desks right now to kind of share some of our observations. So I'm only going to go over a couple of the activities because you had quite a bit to answer. So let's look at on page 1. It says, and this is one that we did together. It says if this is one whole, meaning the 2 hexagons, what is a half? Say on 3 the answer. 1, 2, 3. 1 hexagon. 1 hexagon would be a half. Okay. So now let's look at the second question on page 1. If this is one whole, meaning the 2 hexagons, what is 1/4? On 3, 1, 2, 3.
1 trapezoid.
one trapezoid. So now let's look at the problems on page 2. So now the whole has changed, right? So now the whole on page 2 has changed from page 1. So now, if this is one whole, what is a half? One rhombus, right? And then the second question, if this is one whole, what would a fourth be?
One triangle.
A triangle. Okay, so now what I'd like to do is to go over some of the assessing and advancing questions on your third page. So who would like to share question number 2? Question number 2. And if you didn't get to question 2, that's okay if you still want to answer it. Ricardo, so why don't you read the question?
How did the size of the 1/2 change from the whole on page 1 to the whole on page 2?
Okay, so let's look at it. So everyone turn to the whole on page 1. So the whole on page 1 was what? 2 hexagons, right? So now let's look at the whole, the whole on page 2. What is the whole on page 2? 2 rhombuses or 2 rhombi, right? 2 rhombuses, right? So, Ricardo, how did the size of the half change from the whole on page 1 to the whole on page 2? So how is the half different from page 1 than it is from page 2? How did it change, Ricardo?
They're different because the whole on page, the half on page 1 is a hexagon, hexagon, except the half on page 2 is one rhombus, so the half got smaller.
And why did the half get smaller?
Because there's a smaller space for it to fit.
Okay. Would someone like to add to what Ricardo said? Lola?
Then that would make that your halves or your fractions, they would get smaller because of the whole. It would get smaller. Because if it was big, if the whole was the same as the 2 hexagons, so if they were both 2 hexagons or they're both the same size, each half would be the same size and each fraction would be the same size.
Okay, so building on what you just said, how does the size of the whole affect the size of the fractional piece? How does the size of the whole affect the size of the fractional piece? So turn and talk about it with someone at your table.
It makes the size.
It's question number 3.
It makes the fraction
So what do you think? How does the size of the whole affect the size of the fractional?
I think because on the first page, when it had half of it, it was a hexagon. But on the second page, when it was a half, it was a rhombus.
Okay. Would you like to explain how it affected it?
So I'll just use these
Thanks.
and then you gotta do that.
Half, another half.
I know, but there's
We're not using our pieces. These are my pieces.
okay. I'm gonna throw it out.
You're working on it? That's okay. You can work on it. So what do you guys think? Are you partners today?
So I think that the fractions would get smaller and bigger if it depends on the size of the whole. Because if the whole is super small, that means the fraction would be small. But if the whole is super big, would be bigger because the part of the
You'll be divided
when you're dividing into the half is going to be bigger because the
Okay. Do you agree with Lola? Okay. So who would like to share question 3? Cruz, why don't you share what you have? How does the size of the whole affect the fractional piece? Louder. So, Cheyenne can hear you?
When the whole got smaller, the fraction pieces got smaller too.
Okay. Who wants to add on to what she just said? Who wants to repeat what she just said? Travis, loud voice.
When the whole got smaller, the fraction piece got smaller.
Okay. Ashton?
It affects the amount of shapes inside of it. If it's bigger, it's gonna have more shape, more shape, and when it's smaller, it's gonna have less shape.
Okay. So is it important to name the whole? Why or why not? Is it important to name the whole? We talked about Mrs. Francis in our initial investigation. She didn't name the whole, right? She didn't identify the whole. So turn and talk to a partner. Last question. Is it important to name the whole? Why or why not?
You have to name the whole. Because if you don't, then people won't know what the whole is. Then they'll get the wrong answer, which is bad because people don't want to get the wrong answer. What? Okay. The ones it blinked. To me, it blinked. It blinked is important to me. Okay.
Why?
It's like, why do you guys listen to me? Because how should I say it?
I said anything. I said something.
Okay, can you say a little more?
I explained.
He did.
Because people don't want to get their answer wrong, and they don't want to do that. They just don't want to get it wrong.
I need more I don't know if long I have a name. I have way more I don't need long
Okay. And then you can make comparisons about equivalence, right? Which is what Mitchell was saying. Right? Then you can, once the whole is established, then we can compare, and then we can talk about equivalence, which is what you were saying. But if the whole isn't established, then we can't have any comparisons. Okay, so who would like to share? Let's hear from Shania. Loud voice, so Andine can hear you.
I said that it was important to label the shapes, to make the shapes have names because you wouldn't know if you were comparing the same shape. For example, if a hexagon didn't have a name and you could have compared the same thing by accident.
Okay. Would anyone like to add to what Shania said? Rena, would you like to add? Whether you think it's important to name the whole, why or why not?
Well, I think it's important to label the whole so then people can know if the shape could fit to make a fraction into the whole.
Right, something that I think it was Shania said earlier, then you can make comparisons, right? You can compare, and then you can also start to talk about equivalence, right? But if the whole isn't established, like in Mrs. Francis's example, she had many different, her students had many different interpretations because she didn't establish the whole. Last comment, Alfredo?
This is similar to Shania's. You should, it is important to label like shapes because if like you're doing a test that it says not to use the same shape twice and you don't label it, you may like use it more than twice.
Okay, well thank you boys and girls. So now what we're going to do is we're going to get ready for our next lesson. So what I'd like to do